Hi, let me tell you about another great Manning book. Classic Game Programming on the NES. Make your own retro video game. Written by Tony Cruz.
In the late 70s, video games like Space Invaders and home consoles like Atari 2600 and Intellivision emerged. In 1983, Nintendo launched the Famicom in Japan, featuring games like Super Mario Bros. It was rebranded as the Nintendo Entertainment System, NES, in 1985 for the USA and Canada markets, and became a bestseller, still cherished by retro gamers today. This book offers a comprehensive guide to NES game development, from the basics to understanding game mechanics, now achievable on modern computers with third-party development tools. This guide aims to create a simple, playable game that demonstrates various game concepts and features of the NES platform. We'll develop a space-based shoot-'em-up game inspired by Astrosmash, exploring game structure, 6502 assembly language programming, graphics creation, controller input, collision detection, score tracking, and sound effects. These concepts can be applied to other game genres. The NES console, powered by a variant of the 6502 processor, the Rico 2 A03 CPU, features a custom picture processing unit, PPU, and audio processing unit, APU. Its cartridge interface allows for hardware expansion. The NES architecture comprises the CPU with 2K of RAM, the PPU with 10K of ROM or RAM in the cartridge and 2K of video RAM in the console, and the APU for sound output. The game cartridge contains the program and data space, graphics pattern tables, and optionally, extra RAM. The NES uses a modified 8-bit 6502 microprocessor. We'll use 6502 assembler to write games, as original NES developers did. Learning 6502 assembler allows you to maximize the hardware's potential. Don't be daunted by assembly language. 6502 assembler has a short list of instructions to learn. Retro consoles like the NES are increasingly popular for collecting, playing, and discussing. Retro game development can enhance understanding of underlying concepts and improve skills for modern platforms. Working on retro systems can also serve as valuable training for modern limited systems like mobile phones and tablets. This guide breaks down the structure of a game into various components, providing detailed explanations for each. The game code begins with setting up the console, which involves waiting for the video hardware to be ready, clearing memory, initializing sound hardware, and detecting connected game controllers. The intro screen provides information about the game. It can be a single screen with a title image or multiple screens with more information. An options screen can also be included for player configuration. Before displaying any screens, we need to set up the graphical patterns for the title screen. The NES uses fixed 8x8 pixel patterns for graphics for both the background tiles and sprites, which need to be loaded from the game ROM into the console's video memory. After displaying the title screen, we create a logic loop that waits for input from the player controller. This input can be a button press or navigating through menu items. During this loop, we can animate objects on the screen. The game loop is the main engine that controls the game logic. It consists of sections such as getting player input, moving the player character, initializing spawning enemies, moving enemies, detecting collisions, and animating objects. Difficulty and level progression can also be implemented. The NES's graphics chip, the PPU, handles drawing the screen. Changes to video memory can only be made during the V-blank period when the PPU is not busy drawing the screen. The V-blank signal triggers an interrupt for the CPU, calling a defined section of your game code where any changes to video memory can be made. Providing an ending for the game, such as a score summary or a graphic, gives players closure and a chance to review their performance.
Get this book at manning.com